the temperatures in this area, because of the ice melting, are more conducive to supporting the life of those little krill. So what do the krill, what do? They go from here up in here. But the whales don't know that. The whales come up here looking for food. They're like, yo, where's my food? But they can't find it. So they swim back down here to spawn. And what scientists are noticing is that when the whales get down here to spawn, they look emaciated. 2010 was the third lowest. And so what's happening here is that we're seeing a change in the amount of snow cover. And you can see here that over a longer term, the snow cover is coming down and lasting less. So we're seeing the ocean is showing that we're seeing more heat gathered in the ocean. And you can think of heat in the ocean as sort of like an energizer battery. You know, when you go over, when a hurricane moves over the ocean with high heat content, it's like adding high-test gasoline into your car. It gives it more efficient fuel to work and operate on. So that happened in Hurricane Katrina in 2005. The storm moved off of South Florida, hit the loop current. The loop current was 90 degrees. Boom. Went right from a Category 2 to a Category 5 hurricane. There's a little data glitch over Africa. But over here, generally it's kind of reddish, which shows you it's warmer. It's able to hold more heat. So these rainfall patterns are taken by NASA's TRIM satellite. So it's satellite orbiting the Earth, looking at the rainfall and all that sort of stuff. And we can see different patterns of where heavier rainfall is falling in the tropics. And we can see this every day. And we can take a look at flooding that's going on along the river. And we can go in a little bit closer. And we can see how wide, you know, the river has changed. As a matter of fact, we can measure it. We say, how far is it from there to there? 427 meters. So we can do a lot of measuring with this kind of tool as well. We can say, you know, that's not usually that thick in this area. But if we go down here and say, you know what, the river here is usually pretty thin, but how wide is it here? 261 meters. So if you have satellite imagery, after you have a disaster or a flood, you can use the measurement tools to figure out how wide of an area there's flooding. How long is that road that you need to drive down to get to a certain location? And if you don't like meters, you can change it to kilometers. And if you don't like kilometers, you can change it to feet if you want to. So we can have the option of changing this all over. So that was a small little high-resolution satellite image in Brazil. And we can come out and look at this, these anomalies. Now this particular data set is called sea surface height anomaly. What does that mean? Well, when the ocean warms, it expands and it gets higher. So there's another satellite that orbits the Earth called Topex Poseidon, and it measures the height of the ocean. And what you're seeing here is the height of the ocean. Now keep in mind, when it's warmer, it's higher. When it's colder, it's lower. So we color-coded this to show warm temperatures as higher water, cooler temperatures as lower water. So all these different things here, it's kind of like what's going on here. What's happening here is that the Gulf Stream is coming around here, and it's going here, but when it comes up here at a fairly great speed, it spins. It creates little eddies. And these eddies of spinning water are warm and they pull the warm ocean temperature up to the top. But when you pull warm ocean water up to the top, cold water replaces it. So you get warm, cold, warm, cold, warm, cold. Where you have these warm temperatures. And not only is it warm, but it's higher water. So this is a signature of a big El Nino. And when this develops, this changes global weather patterns because the jet stream in the atmosphere changes. There's more moisture in this area to entrain into developing weather systems. And that's what I showed earlier in precipitable water. Last year we had a big El Nino. And last year in the mid-Atlantic area of the United States, we had very big snowstorms. So let me take you back really quickly. And what the cloud fraction looked like, or total precipitable water. This is during an El Nino where there was much more moisture. You can see the moisture streaming up out of El Nino, coming right up into the east coast of the United States in February of this past year. When there's a La Nina, these water temperatures are cooler. And so we don't have as much moisture available above the cool ocean waters, so there's less likely of a chance that that moisture is going to get entrained up into weather systems that affect. This is from the Extreme Ice Survey, James Baylog, who has put in cameras at 36 different glaciers around the world. These waves are probably 80 feet. We'll put it in reverse just to show you the incredible 2007.
How time lapse is that?
It's 1 day.
1 day.
Happened in 1 day. So this is the weak part, and as soon as that broke off, the equilibrium of this particular iceberg now has changed, and it's now looking to equalize itself. So what you see above is only 10% of the glacier that is the iceberg now below that. It's incredible. Moving about 70 to 80 feet per day, per day, sorry. So it's really important to look at all these different elements and these different data sets from satellites, from Earth in situ observations. Now when sea level rises, it rises in a way that move that forward for a second. Impact, if it were to rise 1 meter, as we zoom down into New Orleans, what the implication could be. This is New Orleans right here. New Orleans is already up to 11 feet below sea level, and it's continuing to sink each and every year. But this is what's critical. All of the delta is underwater. And as you know, deltas and wetlands are critical in protecting the coastline from floods and wave action when storms come in. So this just, a 1 meter sea level rise is going to significantly impact the coastline. Take a look at South Florida. This is Miami, Florida. So the water of a 1 meter sea level rise will get into this area here, impacting hundreds of thousands of people. Pardon?
Do you know when that?
I think a 1 meter sea level rise was initially predicted in the IPCC report of about 100 years. Some people think that that's too fast. Some people think that's too slow. So the science is still looking at it. Gas vision touch table and zoom right into the coastal area in northwestern India which is a very popular area and needs to
Gujarat.
be protected.
Gujarat.
Gujarat. This is the Gujarat state, and it's very important to keep monitoring this and monitoring the effects of climate change, and particularly sea level rise. Because as we zoom right in, we can see that there's much vulnerability that's happening in this part of India. And as sea level rises, there's a whole bunch of areas that where ecosystems will change and things will change, impacts on people will change. So we can help to monitor that, and we can help to communicate that through not only television stations but to the Indian government about how these changes might be impacting people and how you can do adaptation and mitigation practices to help to protect this.